Just go to my Jupyter notebook. Here, what we are going to do is we have the telecom customers dataset, churn dataset. Okay, we are going to use that dataset to predict which customers are more likely to leave and which customers are less likely to leave. So what we are doing is, as part of this today's session, right, and the code walkthrough, we will look at how we can predict the class label. Along with that, how we can predict the probability also. For example, my model predicted the class label for a customer as 1, which means he's going to leave my business. Along with that, if I predict the probability, okay, what is the probability this customer is going to leave my business? If that probability says something like 0.8, that means there is a higher chance that this customer is going to leave my business. Customer is going to leave, but again, what is the probability? There is a higher chances that this customer is going to, leave our business. He requires, immediate treatment. In the sense, we have to contact him immediately and find out from him. And what is the problem? Why is he not renewing his other services, value-added services from us? Okay. Okay. Now I just explained. I just gave you the context about this code snippet. So to start with that, what we do is we import all the necessary packages, the pandas and numpy. This is these two packages are used for data manipulation, numerical operations. And we imported the SHAP. This is the one we used it for interpretability, explaining the feature importance. And then next one is job lib. So why do we use job lib? We explained as part of linear regression. Why do we have to use job lib? It's used for saving and loading your models. Let's say you trained your model. You want to save that trained model so that you don't have to train your model every now and then. Once you save it, all you need to just take that saved model and then load it for making a prediction. For example, you trained your model with 25 million records. Every time if I want to make a prediction, do you think you can train the model each and every time? For example, 100,000 or 100,000 customers are hitting my user interface to make a predictions, let's say on a daily basis. Let's assume that way. So in that case, what will happen? For each customer, it will train the model with the 25 million records and then it will throw the predicted values to them. That's a overkill. For that purpose, what we do is we simply save the model. Once you save the model, you serve the saved model to the end user using the Flask API or Fast API, so that whenever the user they want to make any prediction, all they need to do is send the inputs to your model via the user interface. The model will, the API, it will simply load your previously trained model. That's it. And then it will throw back the predicted values to them. The next step is the load data set. Okay, for that purpose, we are using job lib. And next one is the Seaborn and Matplotlib. This is used for visualization, okay, to plot the data in charts or something like that. And then we have sklearn, scikit-learn packages. These are called scikit-learn packages. It is used for your machine learning tasks. Okay, the next step is loading the data set. How, right? So this is the given data set. You want to load it using the pandas read underscore CSV function. I just hit that run button. Okay, I just hit this one also. So that will get executed. This code snippet is being executed currently because we could see the star. We need to wait until this one get executed. The next one is also being executed. Let's wait for a few seconds. But before, instead of waiting for that, right, I just walk through this code. So in this case, I dropped the customer ID column. Okay, drop this customer ID column. But before that, you might want to see the data, right? So without seeing the data, if I keep on talking, dropping the customer ID or handling the missing value, it doesn't make sense. What I will do is I just go to this folder and then instead of waiting for this one to complete, Okay, best thing I will just go here. If this code get executed, cool. I don't know why it takes still this much of time. This is where we could see the data set. Even it takes time. Let's see whether, yeah, it got executed successfully. Very good, right? So instead of relying on the Excel sheet, what I will do is I'll just go here in the next line. I just put data dot head of 5. Display the top 5 records. Don't display all the records. Just show me the first 5 records. I want to see the column names and everything. Okay, fine. So here the customer ID, gender, and senior citizen, partner, dependents, tenure, phone service. Likewise, we could see so many columns are there. The churn is the column is your predicted. Sorry, this is your labeled column. Okay, the churn is the labeled column. The rest of them are your features. The features, right? You need to find out which features are required, which features that you don't need it. The quick way of finding out is, right, whatever the unique number columns like customer ID or something, you don't need it because the customer ID is not going to be helpful in terms of predicting the customer churn. Okay, so hence we can drop these kind of columns. Okay, so it's a telecom data set. You can see that the telecom related thing, right? The streaming movies, right? Have the subscribe for streaming movies. Have this subscribe for the streaming TV, and then what kind of payment that method that you are using it. Okay, and then paperless billing, are they preferring it? Monthly charges and total charges, and churn, no, no. And this customer, you left the business. So these are the historic data. We have it. The next step is, we need to do the data pre-processing. As part of that, I'm going to drop the customer ID because it's a unique number column. It's not going to be helpful in terms of predicting my the target output feature, in this case churn. Okay, so and then what I do is handle missing values. What I do is, that we have the total charges, it's a numeric column. In case you find any missing values, right, in this case what we are doing, right, we are converting this to numeric value, and then I'll be using fill any. There is something called fill any function. This fill any function that is available as part of your pandas. So here the data is the, yeah, data frame name. This is a data frame name. Okay, date followed by the data frame name. Whatever the thing that you wanted, you can use the appropriate function. Drop, using drop function, we can drop the column name, and then you can use the data frame name square bracket. I wanted to I want to convert this a numeric value, and then what I do is data dot fill any. There is a fill any function. What it does is, wherever you have missing values are there in this total charges column, it will find out the median value, and then it fill that blank values by median value. So this is how we can handle the missing values. Okay. This is the academic way of doing it. There are different techniques that we will discuss it later. Okay. And the next step is we encode the categorical variables. Here, what we are doing is, right, in the case of churn, we could see the yes or no is there. Okay. As per, this is the rule of thumb. You remember it. This is very important. All your input feature, including your labeled feature, should be a numeric value. It can be a binary value like a 0 and 1. It should not be like a text value. Currently, your churn column contains yes or no. You need to replace yes by 1. You need to replace no by 0. And the next step is outliers. In case of any outliers, you can find out the IQR, and then you can, wherever whichever data you have the outlier values, you can put that, you can cap that value with the IQR, and here outlier mask, right? So in case np dot nan something like that, you can put it, and then fill NA, using which you can perform kind of imputation. Okay, you can put median value and re in place equal to true. Okay, so using the IQR, what we are doing right here, we are finding out the outlier. Okay, those values are less than your the left side of your. You remember the box plot in the anything below the minimum value, anything above the maximum, if you see dot, that means that is an outlier. So how do you address that outlier? What you do is we are finding out this, using this formula also we can find out the outlier, okay, manually without seeing the box plot. With that also we can find out if the given data contains the value less than this one, or the data contains more than this value q3 in this one. So in that case, you can assign it to the outlier mask that value, and then you can put that outlier value is np.nan, okay, not a number or something like that, okay. So and finally, what we are doing is wherever the missing value is there, right, you just replace that with median. And finally, what we are doing is we are splitting the given data into training and test data set. Here I have used the test size as 0.2, which means we are going to split the given data into 80-20 ratio. The 80% of the data, the randomly selected data, that will be part of your training data set, and remaining 20% your test data set. Okay. And the next step is, as part of data pre-processing, I did the scaling. Like I demonstrated as part of linear regression scaling, we did it. So why do we need to do a scaling? So what formula is used in the case of scaling in general? Z-score. How many of you remember Z-score? Z is equal to x minus mu divided by sigma. Okay, that is what you are. So that you don't have to calculate it manually. The standard scaler, what it does, it Z-score, it scale your values using fit transform, and then fit transform and transform. Okay. So what it does is, right, it'll take each and every numeric value in all the numerical column, and then it applies the z-score, and it converts the values as between 0 to some values. Okay, the values are very minimal. Okay, it's the classic example is you have age and income. Age maximum you have 2 digits or 3 digits, whereas in the case of the income, it will not be 2 digits or 3 digits. It can be 10 digits, it can be 6 digits, it can be 8 digits. What will happen is if you train your model with these two columns, the model will get biased with the column that has more number of digits in it. Hence, what we are doing is we are scaling the values using z-score also. But in the Python, we have standard scaler class that is available, using which, as part of this class, we have the fit transform method. So using which we are transforming in the independent variables, okay, independent variables, and then even the test data set also we are transforming it. Next one, okay, we are done with the data pre-processing. As part of that, what we did, we dropped the unnecessary columns, customer ID, and then we did the data imputation, which is nothing but replacing the missing value with the median value of that same column. And then we did the encoding for the target column. This is also very important. Okay. And the next one is the outliers. We handled it. And finally, we splitted the data set into training and test data set. And importantly, we did the scaling also. Excellent. Okay. We did everything here. I just execute it here. And yeah, it got executed. Okay. It's pretty fast. No issues. Very good. The next thing is, yes, I have the training data set available separately and test data set also available separately. I take my training data set and then I'm going to fit the logistic regression, which means I'm going to train my logistic regression with both the input features and the labeled output feature of my training data set using fit. That's why I said even in the case of linear regression, we use the fit method to train our model, and then we apply that trained model on the unseen data or the new data to make a prediction. Okay. So here, look here, the predict is there, model.predict and xtest. Fine. As of now, it is fine. We trained the model. And next run, after you train the model, you can find out what is the intercept value and what is the coefficients value, the beta 1, beta 2 slope values. Next one is I'm going to convert the log odds to odds ratio. So how do you convert the log or odds ratio? This is an interview question. You convert all your coefficients using the exp function. Okay. If you take an exponential of your coefficient, it will become an odds ratio. Why do I need to convert log or odds ratio? By default, when you train your model, the model will give you the coefficient values in terms of log odds. Very difficult to interpret. For that purpose, we convert the odds ratio. How do you convert the log odds to odds ratio? You take an exponentiation of your coefficients, it will become the odds ratio. Okay, and then you create a data frame for interpreting this for our interpretation. Okay, the column, for example, the dependence column is there. What is the log odds ratio and odds ratio? Right, along with the log odds, I'm displaying the odds ratio also along with the features, the column names. And next one is the sort features by importance. And here what we are doing is, right, those features are really um, contributing to my model's accuracy. So that is the one I'm going to sort it here and display the coefficients. Okay. And finally, we are plotting the importance, which features are really helpful, which features we need to use it in our model to train the logistic regression. Okay. So in this case, this plot will help you intuitively to find out which features are really helpful in terms of predicting your model. And if you find those features are not at all helpful, you can knock out those features from your data set. Okay, before you train your data set. Okay, train your model. Okay, next one is I train my model. I'm going to apply the train model on the new data to make a prediction. And then here, for example, any new customer comes, right, based on the past patterns learned by my model. If I apply this model, it can tell, hey, this customer is more likely to leave, man. Okay, you need to be cautious. Call him as soon as possible. He's a high risk customer. He's a medium risk customers. You can also classify it based on the threshold that you are going to define it. What is threshold? I'll discuss it a little later. So you apply the predicted values on the unseen data or the new data. So this one will tell, right, which all customers are more likely to leave. It will flag, one, those customers, the value predicted as one, those customers are more likely to leave your business. Okay, more likely to leave so and so customers. I understood because my model flagged one against those customers. Is there any possibility, can I display the probability also along with the class label like 1 or 0? Yes. So in that case, predict proba. You need to use predict proba. So using predict, it will help you to predict the class label. But this is the one will give you the probability anywhere the value between 0 and 1. Okay, depends on it varies from customers to customer. Okay. And then next one is cutoff. Okay, define the cutoff threshold for your classification. Okay. So what do you mean by cutoff here? See, the simple example is my model predicted, let's say I have almost 100,000 customers are there. My model predicted almost, right, 20 percentage of my customers are going to leave. As per my model prediction, 100 out of 100,000, 20% of my customers are, let's say roughly speaking, 20,000 customers are going to leave because my model assigned one or predicted one for the 20,000 customers randomly. Do you think we can call all the 20,000 people and asking them, hey, what is your problem? Why you are not purchasing? Why you are not renewing the service like how you did it in the past? Do you think practically you can call 20,000 customers? It's not possible. So again, what we do is by setting the threshold or the cutoff value 0.5 or 0.7, those customers probabilities are zero point 0.9 and above. You take only those because those customers, my model assigned the probability zero point 0.9 and above along with the class label 1. The class label 1 is nothing but churn. Only take only that customers, filter only those customers, and then you call them. When you apply this filter, what will happen? If you apply the threshold, what will happen? Let's say, instead of 20,000, it will boil down to 300 customers or so. So in that case, instead of contacting 20,000 customers, you can probably write out, nowadays bulk email and bulk WhatsApp options are available. You take only those 300 customers and then you can send an automated email and, you just send some email saying that, hey, you have an offer, special offer, being a long-term customer, you're eligible for so-and-so discount, something like that, the customer will be happy, right? The chances are that the customer is not going to leave you. Here, what we are doing is we are finding out the high-risk customer. What do you mean by high-risk customer? How do you define high-risk customer? The zero point 0.9 and above probability or high-risk customers. It is up to you. You need to decide zero point 0.9 or zero point 0.6 or zero point 0.8 and above. Those customers predicted probability is zero point 0.8. Let's they are they are also risky customers, and in that case, right, the affordability. Okay, so for example, if you can afford based on the number of your customer base, my number of customer base is just 100 customers are there. So in that case, if you use the default, if you use the cutoff value as zero point 0.7, zero point 0.7 is a probability, guys. Those customers, my model predicted zero point 0.7 and above, which means those customers are going to leave. So zero point 0.7 and above, right? Almost the let's say you have 30% of customers. Calling the 30 customer, because those 30 customers probability are almost the mix of zero point 0.7, 0.8, zero point 0.9, or zero point 0.7 and above probability comes around, right, almost 30 customers. Calling the 30 customer will not take much time. If you have 25 million customers, 1 million customers, right? So in that case, you will be just, trimming, right? You're skimming, right? You're just skimming the customers who are the potential customers and also who are more likely to leave. Zero point 0.9 probability and above, right? They are very risky customers. Any time they may leave. Probably they would have left. Okay. So, right. So what we are doing is we are defining a cutoff or threshold. And then what we are doing is we are convert the probabilities to binary labels. Okay. For example, a customer is, let's Ashok. My model predicted the class label for him as 1. I just write it here. For example, Ashok is a customer. For him, my model predicted the class label as 1, which means he's going to leave my business. This is your class label. Okay. This is a predicted class label for Ashok by my model. And the probability also, we are going to assign it to each and every customer using predict proba. So in this case, the probability is 0.89. That means almost 0.90. That means, this customer is a risky customer. Anytime he may leave our business. Is a critical to our business. So in that case, right, again, you need to check, how much, what are the total charges he paid so far. And if he spent more money, right? So in that case, right, he's a potential customer. So you filter it like this, right? You just classify high risk customers in your dashboard, and then medium risk customers and low risk customers. So in that case, the first focus will be on high risk customers. You need to attend to these customers instantly. Right? For that purpose, yes, we need to predict the class label. Along with that, we need to predict the probability also. And again, the cutoff. So here, right, if you don't specify 0.8, here, for example, in this case, 0.8, there are some customer, right, they are 0.60, their probability. Unless, another customer is Kumar. He is also my model predicted him as, this customer is going to leave my business as 1, and here 0.60 probability. So in this case, you need to take a call. So you wanted to focus only on the very high risky customer, which means, 0.8 and above customers are considered as high risk customers, and 0.60 low risk customers, something like that, okay, or medium risk customers. So you need to group the data where the class label and probability got assigned, right, based on your criteria. You need to define the criteria based on which you need to do kind of clustering. So those customers are 0.89 and above, you need to contact them immediately. What this step does is, let's say here, 0 point, instead of saying 0.5, this is the default threshold value. Remember this is the interview question. They'll ask you what is the default threshold value. In the case of logistic regression, 0.5. Okay, you can specify what are the value that you needed. It is up to you. For example, 0.8, if you say, right, if you put it here, hey, to take only customers, those probability got assigned with 0.8 and above, they are high risk customer, rest of the I don't care. So in that case, the 0.89 probability assigned to only few customers, you take those customers and contact them. and then find out their their concerns, and then address it, so that the chances are high that you can retain those customers. Low risk customers, you don't have to worry too much about them, because if you want to contact all the customers, high risk, medium risk, low risk, if you try to find out the total number of hit counts, it comes around, 5,000. It's very difficult, right? High risk, hardly I could see 100 customers are high risk. Medium risk, 300 customers, and low risk is, 5,000 customers are there. Do you think 5,000 customers you can put staffs to contact each other? So for that reason, you need to determine the cutoff value here. So ideally, you can put zero point 0.8 or above, something like that. Okay, it is up to you. The default value is 0.5, because don't take all the many customers. Risky customers are there. How risky are they? You determine the risk factor based on the probability. Correct? The higher the probability, the risk. So for that, you need to put the cutoff value 0.7 and above. So those customers, my model predicted 0.7 and above, you convert them as 1. Okay, that is what we are doing it here. Okay. So if the probability values are greater than, for example, you have zero point 0.7 and above, you convert that probability to binary values based on the cutoff. That means, you consider only those customers are about to leave the business. The rest of them, we don't care. Okay. The chances are very slim. Okay, what is next? The next one is the accuracy. So now that we've trained the model and then we predicted the model, we defined the cutoff, everything is good. The next one is the accuracy. We want to check how accurately my model classified the churned customers as a churned customers, or non-churned customers, non-churned customers. Okay, that is what we can find out with the help of accuracy. As I told you, accuracy is not the be all and end all kind of metrics, because in the case of imbalanced data set, the accuracy matrix is not going to be helpful. It is biased towards your majority class. Okay, now we trained the model and we predicted the model. Now we are going to save the model using job_lib.dump. Okay, the model name is churnmodel.pkl. Once you save it, you can use it later point in time. And then we have scalar, right? We have in the above, we scale the data. That also I stored it as a scalar.pickle file. And next, what I do is I load and predict. In this case, I'm going to load both the model as well as the scalar.pickle also. And next one is, yeah, so loaded model, right? With the loaded model, we are going to make a prediction for any new customers or something like that. And finally, we have the SHAP. Okay, SHAP is a package using which, right, you can find out the feature importance table, which features are really helpful. We have a lot of columns are there, features in my data set. So which features are relevant, which features are not relevant, it is very difficult to find out, right? You cannot make any guess. Even though you have domain knowledge, you can guess some extent. But simple rule of thumb is, if you in your data set, if you have any unique ID column, you can drop it. That is not going to. And again, we see phone number, email ID, those columns are not required. You can delete it. There are certain things you can delete it point blank. There are certain columns you cannot delete it, right? So in that case, you cannot judge, right? So you leave it with something called sharp.explainer. So you will judge and tell, hey, so for this tenure, right, the log odds is -1 and something like that. So we convert this up in odds ratio. If you want to convert this odds ratio to probability, what you need to do is you need to take this value 0.292 divided by 1 plus 0.292. So this is the one will give you probability. If you want to convert the log odds ratio to odds ratio, you need to take the exponentiation of this value. Okay, exp of -1.22 and other things. Okay, if you do this, you will get odds ratio. And even if you find it difficult to interpret, so you can convert the probability. So how do you find out the probability from the odds ratio? So odds divided by 1 plus odds. This is the one will give you probability. Okay, that's what we can see that here. The feature importance tables, right? So we can see that here. And here, 1 second, I just clear this one. So, and instead of, going by that, text kind of data, right? So you can just plot it in a chart also. One second, I just the SHAP is helpful in terms of plotting the chart also here. No, no, you need to use some SNS bar plot. Yeah, from that feature, right? You can plot it here. So you can see that the tenure is this rectangle is not that big, okay? And those features like total charges, monthly charges, it goes above this cutoff line. That means, right, these features are helpful in terms of retaining in your model. Probably you can knock out these features. These columns are not, helpful in terms of predicting the customer churn. The total charges, monthly charges are helpful in terms of predicting your churn, and paperless billing and multi-lines, multiple lines. So whatever the length, whichever the columns, rectangles, longer one, you can keep only those columns in your model. Blindly don't keep all the columns in your model. If you keep all the columns in your model, what will happen is if the volume of data is very high, it will slow down your model training time. And also what will happen is it will add noise to your model. It cause some error to your model. Okay, the model can learn wrong patterns from your data. Fine. So this is what we can see that here, it gives another important, nice chart here. Feature 18, feature is in the column 4 and column 14, the feature 14, right? So, and as you go down, you can see it got narrowed, and these columns probably you can close your eyes and remove it from your model. Okay, you don't have to include all these columns, except, those columns the length are, very wide here. These columns, 1, 2, 3, 4, 5, maybe, right? 5 or 6 columns you can include. That's all. Maybe 7, 8 column you can include it. Rest of them you can discard it from your model. So using SHAP also we can identify the important features that are helpful in terms of predicting your churn. They will ask you in the interview, how do you do the feature selection? This is called feature selection. Using SHAP, also we can plot the chart. With that chart, we can determine what features that needs to be keep it in my model. Okay, fine. We are done with that. Next one is this chart. Don't worry too much about this, and let us go down and see the picture here. This is called your ROC value. What is ROC? Receiver operator characteristic, this name. But don't get scared with the name. In statistics, only the names are a bit scary. Otherwise, other than that, right, the rest of the actual concept is very simple one. Receiver operating characteristic. ROC stands for this one. And here you can see that there is a diagonally, right? So you can see the line diagonally here. It's a dashed diagonal line. Just above this, you can see that curve. So here, ROC curve, when you see that, right? So in the ROC curve, you have on the x-axis the false positive rate is there. On the x-axis, you have the true positive rate is there. The interview, they will ask you definitely this one. So what is ROC curve? Okay, receiver operating fine. So in the x-axis and y-axis, what value plotted? False positive and true positive rate. Fine. How do you interpret this? If the curve is, let's say if the curve goes something like this. The curve goes something like this. Sorry, not this one. If the curve goes something like this, and then it goes like that means, this is a best fit model. Okay. So that means the model we're able to predict well the churners. Okay. But anyhow, this is also fine. Okay. If you see something like this, right, very closer to this diagram, that means that model prediction is not that accurate. Okay? This model is useless. What is the diagonal line? If I don't have, if I don't fit the logistic regression model, and if I make a random guess, so what is the thing, right? What is the thing that is what it shows here. But here, after using the classifier like a logistic regression model, what is the improvement in terms of identifying the churners? So with this random guess compared to the random guess, what is the purpose of this model? How well the model helps me in terms of identifying the churners. Random guess, right? Very difficult, right? So you just look at some customers and when you make a random. So this basically tells us with the model, without model, what is the what is the advantage? Okay, so if the curve goes above like this, that means and it's not going, it's not overlapping with your diagonal line, then it is good. It is going up, but still, had we got the curve something like that, that means the model was able to identify or predict the churners very well. It was able to predict more number of churners, but unfortunately, it's not that. But again, it's not that bad. So the area under the curve, this is also called the area under the curve. The area under the curve should be 1. Any value closer to 1 is good. The model is good. Okay. That is what your ROC curve is all about. ROC AUC curve, they say. Next one is the confusion matrix. Okay, what is confusion matrix? We discussed yesterday. So, right? So, confusion matrix is for, you can use the confusion matrix for your classification model, right? So, in this case, we are predicting the churn, right? The confusion matrix, we can use it to evaluate the performance of our classification model. So, in this case, it consists of four values: true, positive. This is your true positive. Sorry, this is your true positive. Okay, this is your churn. Okay, this is your actual. This is the predicted values. Okay, this is your true positive, and this is the true negative. True positive and true negative. So, what is true positive? The number of correctly predicted churn cases and the number of correctly predicted known churn cases. Churn means, the 932 customers, they are not going to leave your business. 211 customers, they are going to leave your business. Okay. So what is this one? What is this one? The false positive and false negative values we discussed. In this case, the false negative is 162, which means the model incorrectly classified 162 customers as no churn when they actually churn. Okay. So actually, if you see this is actual, right? Actually, they churned 162 customers. This column is your predicted column. Okay. The actually 162 customers they churned, but your model wrongly classified these 162 customers, they did not churn. Okay. This is very risky here, right? And what is that false positive? The model incorrectly classified 104 customers as churners. Actually, they are not churners. It's something like wrongly classifying no churners as a churners and also incorrectly classifying the one second. Where is the spotlight? Okay. So incorrectly classifying 162 churners as non-churners is also problem. In this case, it is okay. Okay. If your model wrongly classify no churners as churners, it's fine. But actually, you have we could 162 customers. My model was not able to classify correctly. In that case, if you don't contact these 162 customers, who knows? They may be a potential customers. You are going to lose the customers. Okay. Ideally, this 162 value is supposed to be here. Okay. Unfortunately, model failed to classify correctly as a churners, right? It was unfortunately, or it failed to correctly classify 162 customers as churners. Mistakenly, it classified 162 as non-churners. Here, the false negative values, the cost of the false negative is very high. Okay. So now what we do is we can, now we have the values of your confusion matrix. You have true positive, true negative, false negative, and false positive. Okay. So with that, you can find out the accuracy. What is the formula for accuracy? All the positive values, true positive plus true negative divided by all the quadrants value, true positive plus false positive plus true negative plus false negative. This is what your accuracy formula. Okay. What are the improvements that are required in this model? Here, the false negatives 162 tells us that this model is missing significant number of actual churn cases. Okay, what can I do? So how do I address this issue? You can adjust the decision threshold, right? So we have used just 0.5. Probably you can increase it to 0.6 or 7 or so, something like that. Okay, that is one way of we can improve this model, right? So you can reduce this one. And what are the other techniques that we can use it? So you can use different algorithm instead of logistic regression. Maybe you can try random forest or XGBoost model. Maybe those models, even for that model, we will be using only the confusion matrix in the case of classification. That is the reason why I told you today's session is very important. Once you understand this one, the rest of the things are pretty simple. Okay. So maybe if you try with XGBoost, maybe right, it may wrongly predict only 62, the 100 records will go here. So 311 records or customers, it might correctly identify those customers, the churn customers. Okay, you can try different algorithm, and then probably you can balance the data set. If there is an imbalance, yes, this data set has an imbalance, and you can do balancing. How do you do that? We have some small technique, we'll discuss it later. And other step, what you can do it in terms of improving this, you can do feature engineering to capture the better customer behavior patterns. That is where feature engineering is something like adding a new column based on the existing column. So for that, you need to have very good domain knowledge. Okay. Probably if you don't have domain knowledge, talk to the business analyst and discuss with them what best you can do and what additional columns you can bring in here so that the model accuracy can improve. Okay. So now you understood. So what I did here, I just went one step further. I installed the XGBoost. XGBoost is the most popular algorithm, and with that we can improve the accuracy like anything. And again, what I did, a random forest and XGBoost and another model algorithm like support vector machine, XG classifier, random forest. What I did, I took all these three different models. I'm doing the same training, and then I plotted the uh, in all the three models performance here, all the four models, including the logistic regression. Here, which one is good here? I just compared and combined all the four models performance here. So this is how you need to do it. So in this case, what happens? So you can see that this color, right? The indigo kind of color is accuracy, and the yellow color is AUC. If you see, the logistic regression is really doing good job. Okay, and comparatively, your XGBoost also really doing good job. Okay, but again, you need to try with different threshold values. Like instead of the cutoff value I'm talking, instead of 0.5, you can increase it to 0.665 or 7, and then check which model is capturing more number of churners. And importantly, the false negative values should be very less in this case. So in that case, right, you can decide which model is really helpful in terms of predicting your model. Whichever out of the four models, which model's accuracy is very good, that is the model we are going to deploy it in the production system. Okay. In a single session itself, I explained you how you can fit a model and how we can save the model, how we can make a prediction, and right. And also we have seen how to do the feature selection using SHAP, and also we have seen how you can compare that with various models. And I explained the confusion matrix. Go through on this video, and I will share this script and the data set also. You can start practice it and change the different threshold. That is an assignment for you. And then tell me for example, you take zero point 0.6 and above, right, with the different threshold value. So which model is best? Okay, that you can try it out. I'll share the data set also. All you need to do is you just download this IPython notebook, and then what you do, right, you download the data set also, and then open this file that I'm sending it to you in the WhatsApp. How do you open it? So you just go to your WhatsApp and download that IPython notebook that I'm sending it to you. And then what you do is, right, you open your Jupyter notebook, and then wherever you download that IPython notebook, you just drag and drop it just beneath this name here. Okay, here into drop it. When you drop it, you will find a button like upload. When you click on this, that will get loaded. My script will get loaded. When you click on that, you can find my script here. Okay, you can find my script here. So and then what you do is you just adjust the threshold and see, and also based on the recommended features, those features are really helpful. Okay, feature 4 in the sense, right? You need to go and check what is feature 14. So like something like that. in your columns order, you need to go and check, right? So which for that, what you need to just go up here, and then this is where feature 1, feature 2, feature 3, 4, 5, 6, 7, 8, 9, 10, 13, 14 to tech support, right? So that is what your feature 14. So the feature 14 is also important. That is what the we can see that feature 14 also good, and because obviously this is the common sense. The technical support is not good, customer is going to leave your business. Hence, technical support column, if you include it in your model, it really makes sense. That is crucial to improve your prediction. Okay, so likewise, you need to include only those features recommended here, right? For example, those features we can see highest length up to this feature 11, include only that one. But in my case, what I did, I included all the columns. What you do, right? You can include only those columns recommended by this SHAP, and then fit the model, and then you can experiment it. Okay. So two assignment for you. Try with different threshold, and then try with the features that are recommended by your model. Very interesting, isn't it? So with this, hope you understood, right? So I walked you through this code step by step, and there are some cases I did not walk you the plot and all, right? So that will take that will you will get tensed, okay, by looking at those code. You don't worry about that. So in the case of real world scenario, when you get in real project, already the customers may be using their scripts. Okay, they will ask you to reuse the script most of the cases. It's like plotting the charts, the ROC, confusion matrix. Already they might have created some functions or methods. All in you just reuse that one. That's all. Okay. Anyhow, I will explain you that one also in the later point in time. At this time, you understand the big picture very clearly. This is very, very important. With this itself, there are some students, right? They cleared